Welcome back to the Deep Dive. Today, we're embarking on a bit of a mission, really. We're aiming to cut through the complexity of modern network infrastructure.
hmm
Our source material, well, it might look like a practice guide for the HPE6-A86 exam, focusing on Aruba networking solutions.
Right.
But our goal is, frankly, much broader than that. We're not here just to help you maybe cram for a test. Instead, we're going to try and extract the most potent nuggets of knowledge.
The key insights.
Exactly. The surprising facts, the practical stuff that's absolutely essential for understanding how our digital world connects, how it stays secure, and importantly, how it remains reliable.
Yeah.
Think of this as your shortcut to, well, truly understanding the backbone of the internet, whether you're taking an exam tomorrow or just want to be genuinely well-informed.
And it's great material for that. It really paints a comprehensive picture. It dedicates about 24% to foundational networking architectures and technologies.
Which we'll definitely unpack.
Yeah. Then 21% delves into the functions and features of HPE Aruba networking products and solutions themselves.
Okay.
Another big chunk, 22%, covers the practical side. Installing, configuring, setting up, validating wired network solutions.
Hands-on stuff.
Right. And we'll also explore troubleshooting, operating, maintaining these solutions. That's about 17%. And finally, managing and monitoring them, which is the last 16%. So it's a really holistic view of what makes these networks tick.
Right. So let's imagine you're building a network, okay? From the ground up, laying those digital pathways for data.
Mm-hmm.
The very first challenge, I think, that network designers face is stopping data getting caught in an endless loop, like a digital echo chamber that would just bring everything crashing down.
Absolutely. A nightmare scenario.
How do we prevent that kind of foundational chaos?
It's a critical problem. And the foundational answer lies with Spanning Tree Protocol, STP.
STP, okay.
Its core purpose is simply to prevent these switching loops. It does this by, intelligently blocking redundant network paths.
Logging them.
Yeah, ensuring there's only one active path, a single loop-free topology. This is just vital to avoid those devastating broadcast storms.
Right, where everyone's shouting at once.
Exactly, and it prevents multiple copies of the same data frame flooding the network. But, here's the deeper insight, maybe.
Okay.
While STP is foundational, it's also, it can be notoriously complex to configure, and it can actually create bottlenecks in modern high-speed networks.
Oh.
So
Yeah.
the real nugget isn't just what it does, but maybe why advanced data centers are increasingly moving beyond traditional STP. They're using things like shortest path bridging or Ethernet VPN to get true active paths without those old limitations.
That's a really good point about its evolution. So, okay, we've sort of tamed the loops, at least initially. But what happens when our network gets bigger? And we need to logically separate different kinds of traffic, maybe for efficiency, maybe for security, even if it's on the same physical hardware.
Right.
That sounds like a job for VLANs, virtual local area networks. They solve that pretty elegantly, don't they?
Oh, absolutely. VLANs offer immense power. On one hand, yes, they significantly reduce broadcast traffic.
How so?
By segmenting the network into smaller, more manageable broadcast domains. So fewer devices get broadcasts meant for others, makes the network more efficient.
Okay, efficiency.
But on the other hand, and this is where it really shines, I think, they improve network security by isolating traffic.
Isolating it.
Yeah. Think about the pain of having to recable or physically move devices every time a department reorganizes or a new project starts up.
Oh, yeah.
VLANs let you logically reconfigure your network with just a few clicks. It makes your whole infrastructure incredibly adaptable to business changes. That's the real agility they bring.
That flexibility, yeah, that sounds like a network admin's dream. But, okay, if these logical networks are separated, how do they keep their identity when they need to share, say, a single physical connection between switches? How does the data know where it's actually going?
Good question. It's all thanks to something called VLAN tagging. Yeah, this process essentially marks the Ethernet frames with a specific VLAN ID. Think of it like a digital label.
Okay.
This tag lets the switches identify which VLAN that frame belongs to when it passes over what we call trunk links.
Trunk links, right.
These trunk links are specifically designed to carry traffic from multiple VLANs at the same time. The tagging just ensures each frame gets to its correct logical destination, no matter the physical path.
Got it. So from logically segmenting traffic, let's pivot a bit to physically boosting bandwidth and ensuring uptime. If you've got multiple physical network cables, what's the main reason for combining them into one sort of Logical superhighway.
That's precisely what Link Aggregation Control Protocol, or LACP, is designed for.
LACP.
Yeah. Its primary function is simply bundling multiple physical links into a single, much faster logical link.
Okay, faster.
And this gives you twin benefits. One, you get a significant bump in bandwidth.
Naturally.
And two, crucially, you build in link-level redundancy. So if one of those physical links happens to fail, the other links in the bundle just keep carrying the traffic, keeps your network up and running smoothly.
So it's kind of like having multiple lanes on a highway, but if one lane closes, the others automatically expand, sort of, to handle traffic. Make sure you still get there.
That's a great analogy. Yeah. Network traffic management on steroids, you could say.
Huh. Okay.
Yeah.
But how do you know that failover will actually work when it really matters? What's a critical validation step for LACP?
That's a really smart question because configuration is only half the battle, right?
Right.
When you implement LACP, a critical validation step is to actually confirm those active standby links are bundled correctly and that the failover happens like you expect.
To test it.
Yeah, you can simulate a link failure to verify the redundancy, and there's a command, the show lackup command on an Aruba switch.
Shulacked.
That'll quickly display all your current link aggregation groups and their operational status. Lets you confirm the bundle is up and running just as you intended. It's not just setting it up, it's proving it works under pressure.
Makes perfect sense.
Yeah.
Okay, we've talked about link-level redundancy. But if we connect this to the bigger picture, network resilience, how do you make entire sections of a network highly available? Especially in an Aruba environment.
Right.
You really want to protect against a whole device going down, not just a single cable failing.
Exactly. And this is where Virtual Switching Framework, or VSF, comes into play.
VSF.
VSF lets multiple physical switches operate as if they were one single logical device.
One logical device. Wow.
Yeah. This provides significant system-level redundancy. So if one switch in that VSF stack fails, the others just take over seamlessly.
Okay.
But what's really fascinating here is that VSF also dramatically simplifies management because you configure and monitor the entire stack as just one thing.
Simplifies things.
And it can even allow for hitless upgrades, minimizing downtime during those crucial maintenance windows. Couple that with LACP providing the link-level redundancy within the framework.
Right.
VSF helps create a truly robust and highly available network infrastructure.
Okay, so building a resilient network is one thing, but keeping it running optimally, spotting issues before they become crises.
Yeah.
That's where effective management and monitoring really come in, right?
Absolutely critical.
How do we keep an eye on all these moving parts?
Well, the primary protocol used to retrieve device info and monitor network devices remotely on Aruba switches is SNMP, Simple Network Management Protocol.
SNMP. Heard of it.
Yeah, it's been the workhorse for network management for decades. It collects data about device health, traffic stats, potential issues across the whole network.
Okay.
Its simplicity is its strength, really.
Yeah.
Allows for broad compatibility. But, that same simplicity means it's often complemented by more advanced tools for deeper insights, especially in today's complex environments.
Right. Makes sense. So that covers the sort of big picture of data collection.
Yeah.
But when something inevitably goes wrong or you just need to do some real-world detective work,
Yeah.
what practical hands-on tools or commands can you use directly on the Aruba switches for troubleshooting?
Good question. For hands-on monitoring and troubleshooting, a couple of key tools and commands are pretty indispensable.
Like?
Access Tracker is incredibly useful. It logs user and device access, gives you a clear audit trail, who connected, when, where.
Okay, tracking access.
Then there's the Show Interface Counters command. That gives you immediate statistics on traffic passing through a specific interface, including any errors. It's usually your first stop for identifying traffic bottlenecks or maybe a bad cable.
Show interface counters.
Yeah, got it. And as we mentioned before, the Show Lacks Up command is essential for quickly checking the status of your aggregated links.
Right, checking LACP. That's incredibly useful for that granular control. But moving beyond individual device commands, what's the game-changing benefit of moving towards centralized, often cloud-based network management solutions? Seems like a huge shift.
It truly is a paradigm shift.
Yeah.
The main benefit of using a platform like Aruba Central is exactly that, centralized, cloud-based network monitoring and management.
Centralized.
It vastly simplifies network operations because you get that single pane of glass, one place to view the entire network, push consistent configurations, monitor performance across all your devices, doesn't matter where they are physically.
That sounds powerful.
But the deeper benefit, I think, is the data analytics and the automation capabilities it unlocks.
Ah, data and automation.
Exactly. Helping administrators predict issues, optimize performance, even automatically deploy changes across huge deployments. That's something individual device commands just can't do at scale.
Right, the scale is key. Okay, and finally, let's wrap up our deep dive with network security. Specifically, how devices and users gain controlled, secure access to an Aruba network.
Crucial topic. When it comes to secure network access control, especially using a tool like Aruba ClearPass,
And ClearPath.
two common and very powerful methods are 802.1x authentication and MAC authentication.
Okay, 802.1x and MS auth. What's the difference?
Well, 802.1x is generally more robust. It often requires user credentials, like a username and password, and can even verify the device's security posture.
Right, more checks.
MS authentication, on the other hand, uses a device's unique MS address, its hardware address, to grant access. This is typically used for devices that don't have a user interface, like printers or maybe some IoT devices.
Ah, okay, for headless devices.
Exactly. But the crucial insight here is that ClearPass integrates these methods and others into a comprehensive network access control strategy, a NAC strategy.
Oh.
It allows organizations to define and enforce really granular access policies based on user role, device type, security posture, location, time of day, all sorts of things.
Pretty specific.
Yeah, it's not just about who's connected, but what they're allowed to do once they're actually on the network. Big difference.
All these pieces have to fit together just right to create the connected world we all rely on.
It really is. And understanding these concepts and tools, it isn't just about, passing an exam.
No, definitely not.
It's about gaining a deeper appreciation for these complex, yet, often elegant architectures that power everything, ensuring the speed, the security, the reliability that we often just take for granted.
Yeah, the hidden infrastructure.
Exactly, the hidden infrastructure that makes it all possible, and it's constantly evolving, too.
And that leads us perfectly to a final thought for you, the listener, to consider. Given this